Alright, page 2. We're now going to look at the actual derivative functions of logarithms and exponentials. And this was originally in class, I was going to use the definition of the derivative to show you how to find the derivative of the natural log of x, which means I was going to show you what the limit as h approaches 0 is of f of x plus h, which would be ln of x plus h minus f of x, which is ln of x, all over h, which is what we did last unit. This ends up, again, I could simplify this because these are two logs, base e separated by subtraction, so I could write that as ln of x plus h divided by x, all over h. And I could continue that process, but I can tell you that it's not as much fun to do right here as it would be in class maybe another day. So if I continue this using the limit function, what happens is, to find the derivative of the natural log of x, what it ends up equaling is 1 over x. So just like the derivative of x squared is 2x, anytime you take the derivative of the natural log, it is 1 over x. So now we're going to look at finding the derivative of e to the x, and we're going to use logarithmic differentiation. I am going to work this one out a little bit because it's actually pretty quick. So if y equals e to the x, if I take the derivative of this, it is, well actually before I even do that, I can't deal with this because there's a variable in the exponent. So if I take the natural log of both sides, then this x can drop in the front, so I'd actually have ln of y equals, the x drops in front, ln of e, and we just talked about ln of e equals 1, so that's gone. So the derivative of, so I haven't done anything to derivative-wise. I've just taken the natural log of both sides, so I've simplified e to the x into ln of y equals x. Now if I take the derivative of ln of y, it's 1 over y prime, and we haven't talked about what that means yet. That's implicit differentiation, but I'm just kind of giving you how this works. The derivative of x is just 1. So if I wanted to get to the derivative of y, I don't have that by itself, so I'd multiply both sides by y. So now the derivative of y equals y, which is weird, but y we started with was e to the x. So the derivative of y equals e to the x, so this is the best derivative ever, because the derivative of e to the x is e to the x. It's equal to itself. So those are both pretty easy derivative functions. You just got to remember them and or write them down in your page of notes when you take this particular test. So we could do the same thing using any base. So instead of e to the x, if I have 2 to the x, and this would work with any base, if I take the natural log of both sides, I would get ln of y equals ln of 2x. The x will drop in front. And if I take the derivative of this, it's just what it was a minute ago. The derivative of ln of y is 1 over y. Implicitly, I have to tag the derivative onto it. And the derivative of x is just 1. This is just a number. If you plug ln of 2 in your calculator, it's some crazy decimal. So really that's the same as if I had 4x over here. The derivative of 4x is 4. So if I just had rewritten this as ln of 2 times x, and that's my coefficient, the derivative of ln of 2x is just ln of 2. And if I want to know what the derivative is, I multiply both sides by y. So now I have the derivative by itself, and I have ln of 2 and y, but y was equal to 2 to the x. So anytime, sorry I'm not even on the right thing, anytime you take the derivative of any base, it doesn't have to be e, this could be 2, 3, 4, 5, 6, it could be anything. The base with that variable stays times the natural log of the base, which is what we have up here. I started with 2 to the x. The derivative is 2 to the x times the natural log of the base. That works up here too. I started with e to the x, I have e to the x, and I would apply the natural log of e to this, but the natural log of e is 1, so that's the reason this is the only one that's left with e to the x. So again, not a horrible one. This is one that you might want to have looking back on your notes to reference, but when you take the derivative of a numerical base with a variable of an x, it's what you start with, just like e to the x, the derivative is e to the x, b to the x, the derivative is b to the x, but you've got a constant to tag on, ln of b. Last one, I think. Yes, last one. Log base b of x. So this is a logarithmic function. So if I apply the circle rule to this, you can, again, this is one of our properties of exponents, the base raised to the power across from it. So this is exactly equal to b to the y equals, and it equals whatever's stuck right here, equals x. Now if I take the natural log of both sides, natural log of b to the y equals natural log of x, this y drops in front, so it's y times ln of b equals ln of x. And if I divide both sides by this to get y by itself, I have y equals ln of x over ln of b. Remember, natural log of b, this is just a number. So whatever you started with here, it'd be like 5 or 10 or 6. And it goes right there. And now I can take the derivative of this. The derivative of y is just y prime. The derivative of ln of x is 1 over x. And this again is like a constant, as if I had 1/4 out in front. And remember, if I had 1/4 out in front, it stays, so the constant just stays exactly where it is, which is on the bottom. It's on the bottom, it stays on the bottom, and that's your derivative. So anytime you are taking the derivative of a log function, just like the natural log ends up 1 over x, that's the same idea. We have 1 over x right there on the bottom, but I also have to take the natural log of the base. And again, that would be the case up here. I would have the natural log of e down there, but the natural log of e is just 1. That's why this one, the natural log itself, clears out to just 1 over x. Down here, you end up with 1 over x ln of b. Note, all that stuff I showed you is just why they come to be. You're not going to have to reproduce any of this at this point. You just need to know that if I'm taking the derivative of an exponential function, this is what I get. Derivative of a log function, this is what I get. Same with e and natural log. End of part 2.